In the previous video, we talked about how to use online financial calculator to calculate the present value of annuity. Now we can do some experiments with these annuity cash flows and the online financial calculator. So if we calculate an annuity with $100 payment at the end of each period, and this annuity has 4 periods, discount rate is 5%. The present value of this annuity will be $354.59. Now I want to see what will happen if we change the periods of this annuity. Let's do the experiment. So we have $100 at each period, and the discount rate is 5%. We have these periods as now I want to calculate 10 periods. And we do this calculation with annual frequency. Let's say the present value of this 10-year annuity, it will be $772. What if we change the periods into 50 years? So the present value of this new annuity will be $1,825.59. What if we have a longer annuity? So the annuity will provide the payment for 100 years. The present value of this 100-year annuity will be $1,984. What if we change to 200 years? The present value of this 200-year annuity is $1,999.88. It's weird. Why when we change the years in a big jump, but the present value of annuity doesn't change too much? To answer this question, we need to have a close look at the present value annuity factor. Let's go back to the string of cash flows of perpetuity and annuity. In this first graph of timeline of cash flows, I provide a perpetuity. This perpetuity will provide you $100 at the end of each year forever. And we know the equation in calculating the present value of perpetuity. It will be $100 over the interest rate. That is $2,000. So now I provide another graph of cash flows. So in this stream of cash flow, you will have $100 in year 5. And you will have this $100 payment forever in the years after year 5. It is very similar to the first graph. In fact, if you standing from year 4 and looking forward, it is a perpetuity. It is a new perpetuity starting from year 4. But this graph of cash flows is different with the first graph of cash flows. Why? Because you will have this perpetuity starting from year 4. So we need to consider the discounting calculation for this stream of cash flow. So now we have a stream of cash flow that with present value at year 4 as $2,000. We want to know its present value at year 0. Let's do this discounting calculation. So you have year 4 future value as $2,000, and the discount rate is 5%. You wait for 4 years to have this future value, and we do this annual calculation. So the present value of this delayed perpetuity is $1,645.4. If we take a difference between this first graph of perpetuity and the second perpetuity, the difference of present value of this year 0 perpetuity and the present value of this year 4 perpetuity will be $354.60. It is exactly the present value of 4-year annuity we calculated before. Now let's draw the timeline of cash flows for this 4-year annuity. So you will receive $100 at the end of each year during year 1 and year 4. So now if you have a look at the second graph of cash flows, and you have a look at the third graph of cash flows, and then you combine them together, it is exactly the first graph of cash flows. So if we have a 4-year annuity and we have a perpetuity delayed till year 4, together they will be exactly a perpetuity from today. So now you can see why we have this discounting factor in this present value annuity factor. Okay, now let's go back to our previous experiment result. So now we know that we have this discounting factor inside the present value annuity factor. So let's compare the discounting factor for these different periods. If you calculate 1 over 1 plus interest rate to the power of 100, it will be 0.007604. It is small. If you calculate the discounting factor as 1 over 1 plus interest rate to the 200 years, it will be 0.000058. It is even smaller. So because these discounting factors for these long periods are both small, so the difference between them is small. That is why we don't see a big difference between a 100-year annuity and a 200-year annuity. So these interesting experiments have some useful implications. So if you want to value $1 in the future, if this money occurs in very future, then the present value of this $1 will be extremely small. Thanks.